This is a video on how to calculate kinetic energy and potential energy. Let's look at number 1. A soccer ball with a mass of 0.7 kilograms is kicked and traveled at a speed of 5 meters per second. Calculate the kinetic energy. So let's start off with our formula first. To find kinetic energy, we are going to use the formula kinetic energy is equal to half mass times velocity squared. So let's find those in our problem. Our mass, I'm going to label with blue. Okay, so our mass in our problem, units for mass is kilograms. So here is our mass. Our velocity, I'm going to label with green. Velocity is units are meters per second. So there's our velocity and we have our mass. So let's plug it into our formula. One half is also the same as 0.5. You can do either. It's a little easier on the calculator if you do 0.5. So I'm going to do 0.5 times our mass, which is 0.7 kilograms, times our velocity, which is 15 meters per second, but we have to square it, so we're going to put the square over the 15 meters per second. So this problem may also look like, you can do this, or you can do this. 0.5 times 0.7 kilograms times 15 meters per second times 15 meters per second. It is the same thing, just written slightly differently. And when we multiply all of that together, our answer is going to be 78.75. Our units for energy are in joules. Our units for energy are joules. Let's look at a second problem. Problem number 2. A car with a mass of 500 kilograms is moving at a speed of 25 meters per second. Calculate the kinetic energy. So to find kinetic energy, we're going to use our formula again. Kinetic energy is equal to 1/2 times mass times velocity squared. So let's find our mass. Our mass is blue. In our problem, mass is kilograms, so 500 kilograms is our mass. Our velocity is green, and that is 25 meters per second. So now that we know our numbers, let's plug in our numbers. So we have 0.5, or 1/2, times our mass, which is 500 kilograms, times our velocity, which is 25 meters per second, and we're going to square it, which is exactly the same as like what we did before. 0.5 times 500 kilograms times 25 meters per second times 25 meters per second. This is or. We do one or the other. And then when we multiply all of this together, we get 156,250 joules. Let's look at another problem. Let's look at one last one for kinetic energy. Okay. Number 3. A volleyball player with a mass of 90 kilograms jumps to spike the ball, reaches a speed of 7 meters per second. Calculate the kinetic energy. Well, let's start with our formula again. Kinetic energy is equal to 1/2 meter mass times velocity squared. So let's find our mass, which is blue. It's in kilograms, so there's our mass, 90 kilograms. And we find our velocity, which is green, 7 meters per second. So we're going to plug in our numbers. 0.5 times our mass, which is 90 kilograms, times our velocity, which is 7 meters per second squared. Or we can do it this way. 0.5 times 90 kilograms times 7 meters per second times 7 meters per second. It is the same thing. When we multiply all of that together, we get 2,205 joules for kinetic energy. Now let's move on to potential energy. Potential energy is a little different. So potential energy, a 25 kilogram bucket of water is lifted to a height of 3 meters. Calculate the gravitational potential energy. So potential energy, or PE, we're going to use the formula mass times gravity times height. So mass, we're going to do blue. Mass is 25 kilograms. Height, we're going to do green. Our height is 3 meters. But wait, we don't have gravity. Well, for our gravity on Earth is equal to 9.8 meters per second squared. That is our gravity on Earth. And so anytime you see a gravitational potential energy and it needs gravity, you're going to assume that the gravity that they're talking about is here on Earth. So it is always going to be 9.8 meters per second squared. So let's plug in our numbers. So our mass is 25 kilograms. Our gravity is always, it's not going to change, always going to be 9.8 meters per second squared. And our height is 3 meters. So 3 meters. We're going to multiply all of that together, and we get 735 joules. So both potential energy and kinetic energy have the same unit of joules. All right, let's look at another one. Number 5. A 20 kilogram flagpole is being raised to a height of 8 meters. Calculate the gravitational potential energy. All right, so let's start with our formula. Our formula for potential energy is mass times gravity times height. So our mass is in blue. Our mass in our problem is 20 kilograms. Our height, which is green, is 8 meters. And our gravity, for every gravity potential energy problem, is going to be 9.8 meters per second squared. So now we have all of our numbers. We're going to plug in to our formula. Our mass is 20 kilograms. Our gravity is 9.8 meters per second squared. That will not change. And our height is 8 meters. After multiplying that out, we get an answer of 1,568 joules. Let's do one more problem. Problem number 6. All right. A 10-kilogram cat is lifted to a height of 2.5 meters to get into the car. Calculate the gravitational potential energy. So let's first start with our formula. Potential energy is equal to mass times gravity times height. Well, our mass, we're going to do in blue, is 10 kilograms. Our height, which is green, is 2.5 meters. Now for gravity, it's going to be the same because we're here on Earth. Unless it states that we're on a different planet, always assume that it is going to be the same of 9.8 meters per second squared. That is our gravity. So let's plug in all of our numbers. Our mass is 10 kilograms multiplied by 9.8 meters per second squared multiplied by 2.5 meters. When you multiply all of those together, you get the number 245 joules.